Welcome back to the MSU Deer Labs online seminar series brought to you by the Mississippi State University Extension Service and the Forest and Wildlife Research Center. I'm Bronson Strickland and I will be the presenter today. I'd like to also acknowledge my co-author, Steve Damaris, colleague of mine and co-director of the MSU Deer Lab. Today I want to focus on all of the aspects of getting a place prepared to plant for food plots. What are all the things you need to do ahead of time, planting equipment, etc. So that's really what this presentation is about, is the background and preparation for a food plot system on your property. Let's talk about soil testing now. This is one of the most neglected activities that can have one of the biggest returns on a meager investment. This is a clip from a publication at Mississippi State from a few years ago, and it's a little bit dated. The price has gone up. You'll see that in this publication it says the cost is $6. It's actually moved up to $8 now. But for literally $8, you're going to have a soil scientist look at all these different properties of your soil and make recommendations for what you need to add to the soil for optimal survival as well as plant growth. So we're going to move through some of those topics now. This is a slide I took years ago, probably about 5 years ago, and this is a dramatic example. I don't think this is going to occur every place. On this particular property, I know the soil pH is very low. How do I know that? I know it from a soil test. In this area, the pH can be as low as 4.8, but it is very routine to get samples at 4.9 or sometimes 5. So literally, you need tons of lime per acre to get the pH up into the 6.5 and close to 7 range. Also, there's various sensitivities depending on the plant or forage that you choose. Some plants are relatively insensitive to big swings in pH. They're going to do okay. This particular clover that was planted was very sensitive. And so you can see where we did nothing. No lime, no fertilizer. Everything else was exactly the same. And look at the stark difference you see. So this particular clover definitely needed a higher pH, and it also needed a boost of phosphorus or potassium or things like that to get that forage established and to get it to grow. So never neglect the $8 investment. And I'm not saying you have to do this every single year. Most people will do it for a year or two, and they'll start to see what the general recommendations are, and they may go every third year. You know, every 3 or 4 years, it's time to get another soil test to see how the pH is moving up or down, or other minerals. Have they accumulated or have they leached away? So I would do it for 2 years in a row to figure out what you have. And then once you kind of figure out the recipe for that plot, you may be able to go 2 or 3 years before you need to check it again. Here's just another example from that same project where you saw the photo on the previous slide. We also looked at a particular forage. In this case, it was deer vetch or American joint vetch. And we were looking at the differences in the biomass that was produced, and surprisingly, even a difference in crude protein. So you see there along the bottom, we have the control, which is where we did nothing, where we added fertilizer only, where we added lime only, and then lime and fertilizer. And notice the big difference. Of course, the best performance was in plots where we had lime and fertilizer, but we got really good results just from adding lime to correct the pH. This particular plant, deer vetch, is a legume, so there weren't nitrogen limitations. So you may see a very different result if you planted something like a cereal grain that's not a legume, lime may not be enough. You may really need the lime and fertilizer to see a good result. But this is just an example to show you the kind of difference that you can see with properly amended soil. This is a slide that's used all the time. I've probably seen it 100 times in different presentations. And the point of this slide is that when the pH is really low, for a lot of plants, they literally are not able to extract and utilize the minerals and nutrients, etc., that are in the soil. So the pH is actually limiting the uptake. And so the way this particular scientist expressed this with their analyses was percent fertilizer wasted. So let's say on the extreme left-hand side here, you had a soil pH of 4.5. With the pH being so low, the fertilizer that you added to the soil, they are saying here that about 70% of it is not going to be used by the plant. As you increase the soil pH and get it up to 6 and then closer to 7, then that means all of the fertilizer that you put in the soil will be available and can be used by the plant. So it's just another reason to not just blindly go out and scatter triple 13 or some general purpose fertilizer like that and not address the pH problems. Address the pH through lime and then add fertilizer. And you've seen on the previous slides the results. Greater survival of your plants, and those that do survive, you're going to have better growth and you're not wasting fertilizer. This depiction here is just to show you how we recommend you take soil samples from a plot. There's going to be variation, soil quality variation, soil properties are going to vary even in a 1 acre food plot. So what you want to do is a minimum of 5 different spots, and the more the better. But you want to walk or drive, if it's a big plot, throughout your plot and take several samples. What I'll commonly do is carry a 5-gallon bucket or some kind of bucket with me. If you have a soil probe, that's great. If not, take a shovel. And you really just want to sample the soil in what we call the root zone of the plant. So you don't need to dig a 2-foot hole. You literally are just getting, the top 6 inches or so of the soil where most of the root growth is going to be for the stuff you plant. So you're getting a good sample throughout that plot. Put it in that bucket and then you're mixing it together. And I'll show you what to do with it on the next slide. On the left, this is just an example publication. You can go to our website, the Mississippi State Extension Service, and type in soil test for wildlife and get a copy of it free of charge. But most every state is going to have a soil testing service, and that is going to be through the Extension Service or the Cooperative Extension Service through one of your universities. So everybody should be able to get their soil tested through the Extension Service, and there's even some private companies now that offer this service well. Generally about the same price. Some services may cost up to $20. I don't know if I've ever seen one that high, but they're usually in the range of $8, $10, sometimes $15. So talk about return on investment. An $8 investment to figure out what you need to apply to the soil and look at the return you're going to get in terms of plant survival and growth. This is what we do in Mississippi. There may be other procedures in other states, but it's really simple for us. We provide a box. It's just a box, and you're instructed to fill that box up with the soil. Again, going back to my example, so for the particular plot I was at, I took several samples, put it in a 5-gallon bucket, mixed it up, and then I'm just going to take a handful or 2 handfuls, whatever it is, to fill that box up. And then you have the identifying characteristics there, You know, the name, the address, field name or number. That might be food plot number 1, food plot number 2, however you want to name it, such that when you get the report back, you're going to be able to relate this particular soil sample to the correct plot on your property. Now I'm going to walk you through a typical soil test report. Depending on where you're at, I'm sure the format and layout will be a little bit different, but it should have the same type of information. And there's more information on here than we're going to talk about, but I'm going to draw your attention to what I think are the most important things. And you'll notice that it's I have circled on the left pH, in this case 6.9, the amount of recommended lime. This is very rare in Mississippi. Must be a soil from the Blackland Prairie or the Delta or something like that to need no lime. And then on the right hand side is an example of a couple of examples of how you can mix and blend different fertilizers to meet the recommendation. So let's start on the left hand side here. A pH of 6.9, as I say, you are doing very, very well. Accordingly, that's why the recommended lime tons per acre is 0. So the soil scientist is essentially saying you don't need to add or do anything relative to pH. Everything's okay. The other things I want you to notice here is we have phosphorus and potassium. And notice the symbols down here, VL, that stands for very low. And the number here, 11, that's the extractable nutrient levels pounds per acre. So the soil scientist is saying there were only 11 pounds per acre of phosphorus. And in most context, in terms of growing plants, that's very, very low. Potassium, 67 pounds per acre, and that's also marked as low. You'll see other things too, like calcium and zinc and things like that. Those are not typically addressed with your normal fertilizers, which you see below here, N, P, and K, N for nitrogen, P for phosphorus. The chemical formulation you'll see on the right-hand side, P2O5, and potassium K2O. Okay, so now we have talked about lime. In this case, no lime is needed. What we have over here now is needed plant nutrients pounds per acre. So the soil scientist is recommending, this is in a 3-year recommendation. And notice it's all the same, but in year 1, here's what you need to do. Year 2, what you need to do. Year 3, what you need to do. And this is just simply the pounds per acre. So you can simply look at this, and however you do it, whatever fertilizer formulation you come across or want to do, the bottom line is there needs to be 30 pounds of nitrogen needs to go into the plot, 80 pounds of phosphorus, and 60 pounds of potassium. So that is what it's recommended. Now, if you move over here to the right on these examples, the soil scientist is giving you some examples, giving typical fertilizer formulations that you're going to come across at the co-op or at the seed and feed store, wherever you get fertilizer. And you'll notice here that just a little recommendation for people. This fertilizer here, 0.46.0, this means this is the amount of nitrogen, 0, the amount of phosphorus, 46, the amount of potassium, 0. So this particular fertilizer is only applying phosphorus. And the 46 stands for 46% of the material in the bag is the phosphorus material. Notice down here we have 8, 24, 24. 8% of the bag is nitrogen, containing nitrogen. 24% phosphorus, 24% potassium. So the soil scientist has developed this formula where you can mix this up. You would need 10 pounds of actual nitrogen. You would need 65 pounds of O46O mixed with 250 pounds of 8-24-24. If you apply that amount and those ratios, you are going to get what is recommended to the left here of 30 pounds of nitrogen, 80 pounds of phosphorus, 60 pounds of potassium. And example 2 is just another formulation. So notice that's 130 pounds of O46O, 231 pounds of 1313, 50 pounds of OO60. So there's a lot of different ways you can do it, and that's why I love it when the soil scientists will actually put here again on the left the pounds per acre that you need, and then you can go about whatever way you want to get those amounts. But they have, again, just provided you some examples of how to get there. Let's look at another example, kind of almost the opposite situation here. This is a very typical pH, at least for my neck of the woods. We have a pH of 4.8. Accordingly, look over here to the recommended lime, a whopping 4 tons of lime per acre. 4 tons per acre to start getting that pH up closer to 7. And it's going to take you a couple years to get there. So it's not going to be instantaneous. Apply the lime in the springtime, and by fall you're going to have a pH of 7. You need to look at this as a 2 and commonly 3 years for you to get there. Now let's look at P and K. Notice here we have 75 units or 75 pounds per acre, which is high. And then we have 169 pounds of potassium, which is medium. That is going to affect now when we get over here to what you need. So notice the soil scientist is not recommending any phosphorus. The reason for that is because right here it's already high. So you're already saving money by knowing what is there and what's not there. You're only applying the minerals that you are going to need. So another good reason to get a soil test. So this recommendation is 30 pounds of nitrogen and only 45 pounds of potassium. And then here's your example here for your fertilizer mix to get there. Another thing I want to point out is that when you are sending in a soil test, you need to provide the soil scientists with the crop that you are planning on planting. In Mississippi, probably like other places, we have a very general category. It's called Category 95, and that stands for wildlife food plots. And generally that recommendation is the assumption that there's going to be a cereal grain like wheat and oats and also some clovers. So we mark the box. You're marking it with your name, of course, and the name of the field. So you can relate the soil test back to, or take a look here, field ID. So this would be food plot ID number 1. Food plot number 1, here's the recommendation. Food plot number 2, here's the recommendation. So you want to identify the box with the plot, and then also you're giving the soil scientists recommendation about what you are planting, and then they are looking at the soil and customizing a lime and fertilizer application for that plot and for that crop that you plan to plant. I wanted to dig just a little bit deeper on how to interpret these numbers that you see representing a fertilizer. If you see below the chart here for nitrogen, ammonium nitrate, the formula is 3400. For phosphorus or phosphate, 0.460, potash, 0.060. What that means, let's take ammonium nitrate for example. The 34 represents 34% of the bag or the quantity is going to be the actual nitrogen in your nitrogen fertilizer. So commonly, and this is an easy mistake to make, is when you assume, hey, I just bought a 50-pound bag of ammonium nitrate, therefore I've got 50 pounds of the actual nitrogen fertilizer. In actuality, all you have is 17 pounds. So 34% of that 50-pound bag, if you're looking at the actual nitrogen, is only represented with 17 pounds. So that is what those numbers mean, and here's how you can apply it. Is, let's say, again, up at the top of the chart, we have the box there of the different formulas and fertilizers, the pre-mixed, fertilizers that you can mix that the soil scientists provided. Another thing you can do, and this is really useful if you are managing a lot of area, acres of food plot. The cheapest thing for you to do would be to look at all of your soil tests and calculate all combined how many total pounds of nitrogen am I going to need for all my plots, total pounds of phosphate, total pounds of potash, and then buy that amount separately rather than buying a whole bunch of triple 13 or a whole bunch of 8-24-24. Buy the exact fertilizer that you need and then mix them together. So there is another step involved. So what you would do is when you get to a particular plot and you figure out, like in this example, I need 30 pounds of nitrogen, 80 pounds of phosphate, and 60 pounds of potash, you're going to use the technique I'm going to describe in a second, and you would just pull those out individually and then mix them in your spreader and then apply it to the field. Okay, so how do you do it? Let me get my little pencil here. This is where I'm at down here. Let's see. Right down here. Okay, so let's say that I need 10 pounds of nitrogen, like the prescription above. I need 10 pounds of nitrogen. How much of the actual ammonium nitrate fertilizer am I going to have to put out to get that 10 pounds of nitrogen? So I'm going to take the needed 10 pounds, I'm going to divide it by 0.34, and that is going to yield 29.4 pounds of the 3400 fertilizer. So let's call it 30 pounds. So you're going to have to put out 30 pounds of the fertilizer to give you the 10 pounds of nitrogen. So just a little tip for you. Again, it's another step, but it is well worth it. If you're going to be applying fertilizer to acres and acres, 5 or more acres, I think it's worth the time and money to do it this way. I included this slide for 2 reasons primarily. Number one, I wanted a slide just showing people, if they've never seen it before, what a lime spreading truck looks like. It's doing exactly as what you'd imagine. There's lime in the back of the truck, and there's a little conveyor belt that goes along and a little spinner plate on the back end of it, and basically as the driver moves along, it's just being spread out. So pretty common sense stuff. The other point I wanted to make is letting everyone know that I'm human too. And what we are doing here is not ideal. So do as I say, not as I do. But I was in a situation essentially where if lime was going to get on the field this year, it had to happen today. So it was just move everything and get out there and get it done. Ideally, what you should see is a disked field. And so the lime would essentially be spread directly onto the soil. So we would have sprayed this field or this plot with an herbicide, killed the vegetation, waited a couple weeks, disked that up, and have almost like a planting surface. Of course, it wouldn't need to be near as smooth as what you would need when you plant, but basically we would want the lime going directly onto the soil, and then we would follow up with the disking after that to try to incorporate the lime into the soil as much as possible. So that is the ideal situation. That's the best way to do it. I included this slide though to show it's really, really important. In my area, like I've said in a previous slide, the pH is going to be somewhere south of 5, and it's just critical that I get lime on the soil. And basically, we just had to make the most of a bad situation and spread the lime on existing vegetation. Probably did not get, well, I know we didn't get the same effect we would have gotten in terms of neutralizing and efficiency and bang for the buck. But that's the only choice we had. And here's a slide at my local place where I get seed and so forth and fertilizer. Um, this is just basically showing what it looks like. This is bulk ag lime. And there's a couple ways, like you saw on the previous slide, you can actually get the place you're getting it from. If they have a lime spreading truck, that's a service they can provide for a fee to come on out and just put it on the field for you. Oftentimes you can rent a buggy from some of these places, a lime spreading buggy that you can hook up to a truck for transport and then hook it onto a tractor if needed. And basically you spread the lime yourself on your property. Those are really your only two practical options. There are some other devices. We have one that we can use on really small scales, really small plots, and pull it behind an ATV. That particular device doesn't spread the lime outward, but basically drops the lime. So think of it that way. You may have seen, like at a Lowe's or Home Depot or something, for residential use for your lawn, how you can spread fertilizer. It has a little buggy that you push, and one particular type, the fertilizer falls on a pan and it spins and it broadcasts the fertilizer out for 4, 5, 6 feet on each side of your little buggy that you're pushing. Then there's one that just simply drops it. So a little paddle is rotating internally every time you engage the wheels and push the little buggy, and it just drops it. And that's sometimes good for seed, for dropping seed on your lawn. So those are your two options, really. And so we have a lime spreader that operates like that as well. And again, we just use that for very small applications. It would be very inefficient to do that at any large scale. So this is essentially what it looks like and what you're going to encounter when you go to get ag lime and apply it on your food plots. We developed a short little presentation that discusses a lot of the issues I've been talking about. If you'll see here on the left, getting the most bang for your buck, a guide for liming and fertilizing wildlife food plots. It is completely free for viewing and download. You can see the web address at the bottom. You also notice all these pictures you've seen too, all three of these photos you've seen in previous slides. A question that I get commonly, and it can be confusing, I totally understand, is there are different products now. I've been talking about bulk ag lime, but there's also now liquid lime that you can purchase, and then of course pelletized lime that again you may see at a Lowe's or a Home Depot or Walmart or anything like that. And it's really common for someone to spread that on their lawn, their front yard or backyard, because it's really convenient. It's something that you can handle. You can buy several 40 or 50 pound bags and get your lawn fertilized that way. But keep in mind the scale at which we're talking about here. And if it's a really small scale, a liquid lime product may be something economically okay to do. And then something, if we got into an acre or two, maybe the pelletized lime. But point your attention, and if you really want to see all the fine details, you can download this publication. But we looked at the neutralizing value of these limes, and using current prices and so forth, we came up with what it would cost you to neutralize the same area of ground with these different products. And so we go from a range of $1,500 per acre for the liquid, $210 per acre for the pelletized lime, and $81 per acre for the bulk ag lime. Here's the main thing to keep in mind with the pelletized lime versus bulk ag lime. Pelletized lime can have its place, even though it's going to be more expensive on a per acre basis. It will neutralize the soil quicker. So you might think, but it's this really big pellet compared to ag lime. But the particles that make up the pellet, once it breaks down, it turns into a very, very fine powder, for lack of a better word, and it will neutralize the soil more quickly. The flip side to that, seems like there's always a trade-off, right? The flip side to that is you will lose the neutralizing effect more quickly. So if you want to spread pelletized lime, for example, every year, that may be a very viable way to do it. If you wanted to do a big treatment or a big application of bulk ag lime, and you may only do it every 5 years, but you're literally putting a ton or two or more per acre, it's going to cost you a lot less. It'll take a little bit longer for the soil to become neutralized, but it will also last longer. So you may be looking at a 4 or 5 year neutralizing effect. That's really the big breakdown. I've never used a liquid lime product, so I don't have any firsthand experience with it, but just really based on price, it's not going to be something that I would want to purchase to do to be able to treat 5 to 10 acres of wildlife food plots.